Good day everyone, and welcome to day 26 of our 30-day structure analysis challenge. I remain Engineer D, and today I will be teaching you how to estimate slab loads. So from here we are actually moving into the main design of these structural members, and the first element we are going to consider is the slab. Like I said initially, the slab carries the dead load from immovable materials and heavy machinery, and the live loads from human beings and other materials that can move. So all our loads for this case is going to be summed up into dead load, which is GK, and live load, which is QK. So today I will show you how to estimate your dead load. Now your slab mainly is made up of the self weight of that same slab, and then other finishes that are used to give the slab maybe beauty or something like that. So you can have your plaster on the slab, you can have your tiles on the slab, you can have an allowance made for a secondary wall or a non-load bearing wall, which is called partition allowance. So you have all these things that you need to estimate the weight, the loads of all these things and sum them together, and that is what is going to give you the dead load of that slab. So to estimate this, the self weight of the slab is simply the thickness of the slab multiplied by unit weight of concrete. So thickness of slab, I used 150 millimeters here. It is not a static value, it is based on the designer, but 150 millimeters is a safe assumption. So by the time I do 150 millimeters, which is 0.15 meters multiplied by 25 kilonewton per meter cube, I have this value. Now you can get the unit weight of the different materials you are working with online. It is not something that you have to cram, but over time by use you will get to know these things off heart. So plaster, the thickness of plaster is 20 millimeters. So converting, we have 0.02 meters multiplied by the unit weight of the mortar. Now you notice that this is not the same with this, because this is unit weight of concrete because it's a slab, whereas plaster is not concrete, is mortar, cement and sand. So the unit weight is less. By the time I multiply it, I have this. Then this is my tiles. The thickness of the tile is about 1 millimeter, depending on the tile anyway. Then by the time I convert, I have 0.001 multiplied by the unit weight of that tile, and I have this. Then the partition allowance is for light partition allowance. You see it as a table. Light partition allowance is usually 1.0 kilonewton per meter squared. If the partition allowance is going to be made up of heavy material, maybe block work or something like that, then you can have 3.0 kilonewton per meter squared. So for this case, I assumed it to be a light material, so I have 1.0 kilonewton per meter squared. So summing all of this, I have 5.171 kilonewton per meter squared, and this gives me my dead load, which will be in UDL form anyway, of this slab. So if I want to calculate my total load for this slab, all I have to do is substitute this GK with 5.17, and then substitute my QK with whatever I am given as the value of QK, and then I can estimate my slab load. Thank you very much for staying with us through to the end of this video. Don't forget to like, comment and continue to follow us even as we take civil and structural concepts one step at a time, making them easier for all of us to understand. Thank you.